Okay, so let's try the next coding exercise. So open the leetcode.com and go to the problem section and just scroll down in the search question, search world search and hit enter. We have the question number 79 and it's come under the medium category. So let's open it. So let's read the question. So this is a 2D array question. So given an m cross n grid of characters board. So there is some board given. Board means we have some rows given, we have some columns are given, and that array is called as a board, right? And a string is given, world. So we have the board is given and we have a string is given, world, and we have to check we given an m cross and grid of characters world and a string world, return true if world exists in the grid. So we have to check if this world exists in this board, right? Then we need to return true. If it doesn't exist, then we need to return false. And how to search, it is mentioned the world can be constructed from letters of sequentially adjacent cells where additions are horizontal or vertical neighbor. The same letter cell may not be used more than once. As an example, so we have some 2D arrays given. So how you construct the 2D arrays? So we have to put like a rows. So there are three rows. So first row, second row, and third row, right? And in the first row we have the four elements, second row fourth element, third row fourth element. So we have given the word a b c c e d. So we have to check whether this word a b c c e d exists in this array or not. So we started with a, then b's, then c, c, e, d. So this word exists. And where we are checking into the adjacent cell. So adjacent cell means the neighboring cell, and we are checking the horizontal. So A, B, C are in the horizontal direction, vertical as well, like C, C, E, and the vertical direction. Then D, E also the horizontal direction. So we can check in the horizontal and neighboring, but it should be the sequential. There should not be like a gap. It should be sequential. As an example, so there is a next word SSE. So this S, sorry, SEE. So SEE also exists. So in the third example, ABCD. So ABCD, ABCB. So we have ABC, right? A, B, C. If you can take back, then B. But it is mentioned the same letter cell may not be used more than once. So basically, once we travel the once letter A, then we can't use the same word again, same character again. So A, B, C, either we can use E or either we can use C. So A, B, C, E or A, B, C, C. But we want A, B, C, B. So which doesn't exist. Even if we start from this A, then A, D, there is no B. So this word doesn't exist in this word. So that's why the output is false. All right. So we have the board length given, and the minimum number of length is one, right? So the board should not be like empty. So at least like one row should be given. All right. And all the letters are the lowercase characters or uppercase characters, or the mix of characters. So that doesn't matter. We have to just check whether the particular word exists or not. So how we are going to like do this question? So first, try to analyze the logic, because if we know the logic, then it's very easy to convert that logic into the either for loop, if loop, while loop, doesn't matter, whatever we are going to use. We If we just know the logic, then we are going to convert. So let's try to see. We are seeing two example. So we have this board, A, B, C, E, S, F, C, S, S, A, D, E, E, and we want to search the this world, whether this world exists or not. So what we have to do, like how you are going to traverse the 2D array. So if you are to traverse the 2D array, we have to run two loops. One is for the rows, one is for the columns, right? So that is totally okay. So we need to run two loops. One is for the rows and one is for the column, because if we have to traverse, right, then we need to traverse for the rows, we need to traverse for the columns as well, right? So let's try to write that at least that point. So we have the board is given. So self dot board is equal to board, and self dot word is equal to world, and self dot rows. How many rows? So how you are going to calculate the rows? The length of the board is the rows. So length of self dot board is the number of rows. And how many columns? Whatever the first element, right? Whatever the first element. So we can get the first element. So how you are going to get the first element is 0. And then we can get the length of the first element, so which is 4. So we can get the length of the first element. So we get the rows and the columns. Then to search anything, we need to run two loops, like one for the rows, one for the columns. So okay, let's run the loop for I in range of self dot rows and for j in range of self dot columns. Then pass. Okay. So till this point, I think like it's like obviously right. It's obvious. So now we have to start from this A letter. So let me put some color. 1 minute. Uh, So we have to start from this letter A. All right. Okay. So because we run the two loop I and J, and it will going like in like this way. First A, then it will go here, then it will go here, then it will go here, then it will go S, then F, then C, S. Because rows, so the three rows of first row come, and then it will check the all columns, one, second, third, fourth, then second row, then third row, then we check all columns. All right. And how you are going to access the particular like element? Uh, let's suppose the board is given, so board of I and then J. So by this way, we are going to access the 2D array. Okay. Okay, fine. So we are traveling. We are traversing this board, right? On the rows and the columns. So how we are going to check? Because right now we are on the first character, right? So whether we need to start from this character or not, because like in this case, SEE, right? So we will come here SEE. We will come here SEE. But do we need to check further or not? How we are going to decide? All right. So because we have to check the whole world. So what we can do is whatever the first character, we will check with the first letter of the world. Right. So if the first letter of the world matches, then we are going to proceed further. All right. If the first letter of the world didn't match, so let's put that condition only, because in this scenario which I have just highlighted, in this scenario we are on the A character. So what is the next step? We have to check whether the element at this position is equal to the first element of the world. So this is my world, right? Whether the element at this position is equal to the, so let's check. So if self dot board, how you are going to get the element on which our array is? 1 minute, what happened? So how you are going to the current element board of I of J. So we right now I is 0, J is 0. So we will not going to put 0 0 because we are in the loop. So we are putting self dot board of ij. So if the first element equal to equal to equal to equal to what? Self dot world of 0 index. Right? If this is equal, then what next? If this is not equal, then like anyhow, like if this is not equal, then we are going to check the next world. So in this case, as okay, let's first focus on this only, in this example only, otherwise we are getting confused. So we are on the first A letter, so we will check, okay, A is matches with the A. All right. But it could be the reason our world is just A. All right. Our world is just A, or our world is just AB, right? Or AS, or just two letter word, right? It could be any possibility. So we are on the first letter, we will check, okay, our first letter matches, which is fine. Then what next? We have to check. So if let's suppose if there is only one letter, then we have to check whether my string get completed or not. All right. So because let's suppose our world is A, so our string is get completed, and we find our string. So how you are going to check? So let's create one more function and self dot. So we are going to create one function self dot search. Let's suppose pass, and we are going to create one function def search. Okay, so we are going to check because we found the A world. Then we will check whether the next word has been searched or not. If the next word is searched and it returned true, let's suppose it returned true, and we found everything, then we are going to return true. If we did not find anything, then we are going to return false. Right? So this is the logic. Only the thing is we need to implement this function search, because first word is okay, first word is fine, first word fine. Now we need to check the next word. But how? In the question, if you read how you are going to check the next word, we can check the adjacent cell. So adjacent cell means if we are on the A, we can check B as well. So we can check this B as well. We have to check this this S as well. We have to check the above location as well. We have to check this as well. All right. So for A, these four are the adjacent, right? So these four are the adjacent words. So we have to check in the right direction. We have to try check in the upper direction. We have to check in the down direction. We have to check in the left direction as well. All right. So let's delete it. So we have to check in all the direction, right? So that's why I created like a different function, because we have to check in all the direction. So basically, we have to check in right direction. We have to check in left direction. We have to check in like upper direction. We have to check in a down direction. Okay. And so how you are going to check in the right direction? Because we are taking just this example, A, B, C, C, E, D. So right now we are on A. All right. So we have to check on the right direction. So how you are going to check on the right direction? So to check on the right direction, we have here our I is 0, our I is 0 and J is 0, 0 comma 0. And here 0, 0 row. So here 0 and 1. So to check in the right direction, we have to increment J. All right. So we have to increment J. Okay. But let's suppose if we are on the E, then again we have to increment J. Then it will become like 0, 1, 2, 3, 4. So we have to put some condition while checking. So, so if so I, but what is I? So we don't know what is I. So we have to pass here I comma j, and it is going to accept I comma j, right? Because right now we are on the 0 0 0. So 0 world is fine. Now which next character we have to find? So because we are on the 0 0, so we have to tell, okay, we are on the 0 0. Now you need to find the next character. So to find the next character, first we have to like put some checks, like, because if we are on the E, then we are going out of array. If we have to check left, then if we are checking this on this like the purple color, then we are out of array. All right. So basically we have to put some if else condition. So if I, so I is for the rows and J is for the columns. So okay, so we are in the right direction. So for right direction, we have to check J. So if J less than self dot calls minus one. All right. So if it is less than column, right, and if you notice here in the question, it is mentioned the same letter, the same letter cell may not be used more than once. As an example, if I give you in this board, if the word is A, B, C, B, so you are on the A, fine. Then you find B as well. Then you find C as well. Then you need to find B again, right? But we already cover A, B, C. Now you need to find B. So you are on the C. So for the C, the adjacent character are this C, this E, the upper which is out of array, and this B. But you can't check this B again. Right? So how we are going to know whether we have already traversed this B or not? So for that, what we will do, whatever the array, whatever the word we are going to traverse, we are like we are like taking one more board, a visited array, and in the board we are putting 0 0 0 0 0. As soon as we traverse A, we are putting here 1. As soon as we traverse B, we are putting here 1. As soon as we traverse C, we are putting here 1. Now if C has to check their adjacent cell B, then we will check if we already visited. If it is already visited, then it is 1. Then we are not going to check. If it is not already visited, then only those adjacent cell we are going to check. So that's why we have to take the visited array concept, because of the condition given in the question that the same letter cell may not be used more than once. So we have to create some visited array just to store some flag. Okay, I have visited the particular cell just because of that. Otherwise, there is no use. So self dot visited is equal to, so how you are going to create this board? So we have to create 3 rows and 4 columns, and all have some zero value. So for I in self dot row, so three rows, and it should be 0 star calls, or you can say self dot calls. All right. So now this our like 2D array has been will be created. Okay, so 0 0 0 0, then 0 0 0 0, or like all the this particular array will be created. Okay, so now we have to check in the right direction. So if we check in the right direction, okay, we are checking whether this array is already visited or not. So how you are going to check? If self dot call, if j is less than self dot calls minus 1, just because of that, so we are not checking this h column. Because if we are on the E and we have to check the adjacent cell, so adjacent cell is the j column, the h column. All right, so we should not going to check. So that's why we are putting some this condition. Also, we have to check self dot visited I j plus 1, because we are checking on the right direction. So self dot visited I j plus 1 equal to 0 if it is 0, right? And but we have to check till till what point we are going to do search, till we are able to find the keyword A. So we are on the A, which is we are on the A, so we found our keyword. Now we are going to find our next keyword, right? So we have to find our next. So now we are on the B because we are checking on the right directions. Okay, self dot is equal to 0. Then what we have to do? Then we have to find and self dot board. Now which cell we need to search? The I will remain same and J is going to increase. Equal to equal to equal to self dot world. All right. So let me do this. Yeah, and self dot world. So which world we need to search? Is it 0th index or the first index or the second index? How we are going to know? So for that, what we are doing is we are passing here initial 0, because for the first we are checking the 0th index, because here we are checking 0 index, so we are passing 0. and here we will taking as a index. So now if it is index as 0, so now we have to check the next word, so which means index plus 1. All right. So now we found the, if these are all equal, if this is equal, right? As soon as like we check if the first word is equal, and then we are checking the next word. So how you are, because we found the next word as well, right? Now we have to check the third word. So now we have to check the C. So now we have to check the third word. So how you are going to check the third word? Again, we are calling the same function, and search. And what we have to pass? We have to pass I, we have to pass j plus 1, and we have to pass the index plus 1. Okay. So if everything will be fine, then we are going to return true. So that's it. And the same logic we are going to write for, we are going to write for for everything. All right. So same. So let's try to write the same logic for the left direction. We are going to modify. Same for the upper direction. Same for the down direction. For the left direction. So the in the left we are decrementing j as well. So we are going for the left direction. So for the left direction, okay, we are checking. So we have to decrease j, that is the j minus 1. So it will be j minus 1, and it will be j minus 1. All right. And here we have to check if so here what we are going to check. So if j is greater than 0, because 0 already checked. All right. So that is done. Now the for the upper direction. For the upper direction means we have to check the rows. For the down direction means we have to check the rows. For the upper direction. So how you are going to check the upper direction? So if I is greater than 0. All right. So so for the upper direction, if we are going in the up direction, then we are doing I minus 1, then j will remain same. So I minus 1 and j is going to remain same. And this is fine. And here as well, I minus 1 and j is going to remain same. And down direction. For the down direction, what we are doing is we are checking the rows. All right. So we are checking the rows. And for the down direction, we are incrementing I plus 1. So j is going to remain same. So I plus 1, sorry, I plus 1, j is going to remain same. And I plus 1, j is going to remain same, which is totally fine. Okay, because we have to check in all direction, because let's suppose if the keyword is a s c c e d. All right. So now you are on the A, you check the right direction. So B doesn't, like S is not in the right, but S is in the down direction. So that's why we have to check. We have to check like in all direction, wherever it is going to find, whether it's in the right direction, in the left direction, in the upper direction, in the down direction. That's why we have to find like in each and every direction. All right. So okay, let's pause. So A is found, then B is found. So we are going to take the, then B is found in the right direction. Then C is also going to find in the right direction. So then again C is going to find. Then again C is going to find. Then again E is going to find in any direction, because we put the four like if conditions. Then D is going to find. But what next? Now for the D, it is again checking, because we found the keyword, but how we are going to know, like it's the end of the world, how we are going to know? Because let's suppose the D found in the left direction. So we come here in this paragraph. So we found the keyword D. So here we found the keyword self dot keyword. But again, it is calling the search function. So in the search function, we are calling the same thing. right? I comma j minus 1 index plus 1. So we are passing the particular index. So here 0, 1, 2, 3, 4, 5. So we are passing the 5. Again, it is calling the search condition. So we have to put some base condition here where it is going to stop. So if index is equal to length of self dot world minus 1, then we are going to return true, because otherwise it is not going to stop. It is again checking left, right, left, right, left, right, up, down, up, down, up, down. We have to stop somewhere. And that's why for after every search, we are going to check, okay, we are on the second index. So let's suppose we are on the A, right? Whether we are going to stop or not, because we are searching from here. We start from the search from here, right? So we found the A here. Now we are again searching, but whether we have to search or not. So we pass the index is 0. So we will check, okay, length of world is 1. 1 minus 1 is 0. Okay, we are going to stop. So that's it. We are directly going to stop. So we are going to stop and we are going to return true. But let's suppose the length of world is 2. So we are not going to stop. So this condition will remain false, right? So we will check in the right direction, left direction, upper direction, down direction. Wherever we will find, then again we are checking. Okay, so whether the world is like we are able to find the world or not. So that's why we put the base condition. But one thing, let's suppose if after doing all the condition, all right, if you are not did not get the true, because you started from the A, you reach here, 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 all right. Now you find every world starting from the A in this case, which is perfectly fine. But in this case, in the SEE, you started from A. All right. So we found like, okay, board Aij, the it did not meet the condition. Then it is going to increment INJ, because it is going to check the next word. Then B, then C, then E. So we reached here. So we reached at here. We reached this E. So let me, yeah, we reached this A, because uh, A is not the first character, then it is going to check the next one. So B is not going to the next character, because it is not even going in this function, because here itself it is failing. Then it is going to check the next, then it is going to check the next, then it is going to check the next. Then it is E. Then it is going to come here S. So we reached here S. All right. So we found the S. All right. Then, okay, so we found the letter here S. So we started from this, because we found the world of 0 at this I of j. All right. Now we have to check in the left direction, right direction, left, right, upper and down. All right. But let's suppose for S is here. Now we have to check F. So on the left we did not find, on the right we did not find, on the upper we did not find, and on the left as well we did not find. That's why we are going to return true, return false. So that's why we are going to return false, so that it is going proceed further, F, C, S, so that it is going to check further, because here S, E, E, so this one is going to find. So this S, uh, this S, this E, and this E, right? So that's why like we have to like check. Along with that, like let's suppose in this condition, I give you one example, A, B, C, B. All right. So we are also putting the condition of visited as well. But let's suppose you started from S. So you reached this S. So this one S. All right. So you reached this S. You found this S. But you did not find the next character. All right, you did not find the A in the adjacent of S. So you are going to mark this as unvisited, because there should be some array which, let's suppose there is a character DAF, DAS, DAS. We need to find DAS. So D is not there, 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 D is not there. D is not there, D is here. So D is here. Now we have to check its adjacent character. So we have to check this adjacent character A. but A is already visited because we started from this A, B, C, E, S, F, C, S, A. But A is already visited, but A is not part of the world because D, it is starting from the D only. So that's why if condition is false, we have to again set the visited array to 0. So if condition is false, then we have to set the particular index to 0. So that looks okay. Let's try to run it. So maybe some issue. Okay, so int object is not iterable. Okay, for I in self dot rows. So what happened? 0 star. So this is not int object. This is the integer. This is the array. So let's try to figure it out, like why it is not working. We have to put here range. We forgot to put here range. Okay, so let's try to run it again. Okay, so some issue occur. First argument must be string or compiled pattern. First argument must be string or compiled pattern. Okay, so here, mhm, if j is less than self dot cause minus one, okay, and self dot world is zero, self dot world is one, search is equal to I equal j plus one. Okay, so some error is occurs of type error. First argument must be string or compiled pattern. So something is wrong here. A self dot calls minus one. So what's wrong? Self dot calls. We already stored self dot calls, which is fine, and in minus one. Do we need to put some bracket here? So like because we are calling the search, but here we are passing the self. So we have to call here self dot search. So everywhere we have to put self dot search. And also like one more thing we like which we missed because we are not setting the visited array, because as soon as we set the first element we have to set it to 1. We have to set it to 1. So let's try to run it. So accepted, so let try to submit it. So our solution has been accepted and we beat approximately 80% of the people and 44% of the memory. So that's the question. Like basically like what we have to do is we start from the first one, and now in the question itself we have to check the urgent cell. So how you are going to check the urgent cell? Up, down, left, right. The same thing we are checking, up, down, left, right. Along with that they have to mention we can't check the same cell again and again. So that's why we take the visited array, because as soon as we get the first cell we are putting as a visited. So I basically means like 1 means visited and 0 means non-visited. So if we did not find anything uh, uh, from that world, so that was from A, we did not find anything, then we mark A as unvisited. So we mark A as unvisited, and we are going to check again and again and again and again. At the last we have to also check whether like our string has been completed or not, whether our length of world is equal to our index or not. So that's it. That's the end of the video. It's uh, I can't say like it's an easy question, but it's not very hard question, so it's come in the medium category, which is perfectly okay. So you can also try this question. Thank you.